So jumping back in with an octagon here, hopefully you were able to kind of figure out this pattern. So the previous one was 5 times 180, so this one would be 6 times 180, and that's 1080 degrees. And then to figure out what 1 is, I take that number and divide it by 8. So that gives me 135. Notice it's been increasing, so we're good to go. Exterior is still 360. And then to just find one exterior, I'm going to do 360 divided by 8, and then that would be 45 degrees. So as we noticed, there was kind of a pattern here. So like these were always increasing by 180. The sum of the exterior was always remaining 360, which meant that each interior increased while each exterior decreased. So the question becomes, what if you have a decagon? What if you have a shape that has 50 sides or 100 sides? Well, we wouldn't want to continue adding to 180 and like trying to do that. There's formulas for this. So what we'll typically call these shapes is an n-gon. So n-gon, n just means the number of sides. So n just means the number of sides. And so, for example, like an 8-gon, well, we don't really call it an 8-gon, we call it a octagon. If it has 12 sides, you'll learn a little bit that we're going to call that a dodecagon. But once we get past it, so we have really big numbers, we call it like a 50-gon or a 100-gon, or 27 would be 27-gon. And that certain polygons have specific names, but some of them we'll just call them n-gons or 50-gon, 100-gon, 27-gon. We just use that number. So we can't really draw a picture of it, but if I go back and I look at this, I had 3 sides, so I did 1 times 180. I had 4 sides, so I did 2 times 180. 5 sides, 3 times 180. Notice like I went from 3 to 1, 4 to 2, 5 to 3, 6 to 4, and then I multiplied that by 180. So to find the sum of the interior angles, all I need to do is take the number of sides, decrease it by 2, so subtract it by 2, and then multiply it by 180 degrees. Now, I want to be careful with that formula because it's not this. It's like n minus 2 times 180. If you do it that way, what's going to happen is you're going to multiply in the calculator first. So you can subtract 2 in your head, so be really careful. We always decrease, we subtract 2, and then we multiply it by 180. So what if you just had to find one angle? Well, if we just wanted to find one interior angle, so each one, same thing. So each interior angle, one interior angle, I would take that previous number that I got, so the number that I got by decreasing n by 2, so n minus 2, and then multiplying it by 180. And then I would just divide by the number of sides that there are. So there's my formula for that. Exterior is always going to be 360. And then to find one exterior, I would do 360 divided by n. Remember that big bar just means divided by. If you wanted to write it this way, you could. 360 divided by n, same concept. Now, there's another pattern here, and it has to do with these numbers right here. It has to do with the one interior plus the one exterior. I'm going to give you a minute, see if you notice a pattern there. So if I add those together, every single time I'm going to get 180. And that's because an interior angle and its exterior angle will make a linear pair. So they should add up to 180. They should make a line. So every single time if you add your interior and your exterior, they should add up to 180. So you can make a little note that like this one plus that one should add up to 180. And I'm going to use that word supplementary. Now, it really helps if you know the name of polygons and you know how many sides each one has. So most of you already know a triangle is 3 sides. We've been talking about quadrilaterals, that's 4 sides. But then make sure that you know the rest of these because these are the ones that have specific names. So a pentagon, 5 sides. Hexagon has 6 sides. Hepta, or we said sometimes called a septagon, has 7 sides. Octagon, 8. Nonagon, so I feel like it's kind of in the name, like nona, 9. It's like nonagon is 9. Deca, you've heard that before. Decade, decagon is 10. And then notice undeca, So like think like uno, like 1, deca, so like 1 and 10 makes 11. So deca is 11, and then dodeca, so like I think dos is 2, and then like deca 10, so that would be 12 sides right there. Now, we only have to worry about these ones because past this, we're just going to call it a gon. So I would call it a 13 gon, a 14 gon, a 15 gon, 16 gon, 17 gon. They don't have specific names, so it's very easy to see the number of sides. For example, this problem talks about a 50 gon. Well, what's n? What's the number of sides? 50. So once you know the number of sides, it makes it a lot easier to use these formulas right here. Now, before we move on, let's go add these formulas to our formula chart. So if you find that colored piece of paper, down here, how to find the angles in a polygon, there's some spots for you to just copy over those formulas. So let's think back. How did we find the interior angle sum? Well, I had to subtract the number of sides by 2, and then I multiplied it by a number, so n minus 2, and then what was the number that we multiplied by? That was 180, so n minus 2 times 180. And then just to find 1, so each interior angle, or just 1, that would be n minus 2 times 180, and then divide it by the number of sides, which would be n. And the exterior sum is always going to be 360. That's the sum. So then just to find 1, or each would be 360 divided by n. Some people get confused by that word each. Each is just saying like, what is one of them? So like if I asked you not for the total of all the angles in the polygon, but just one, that's just like saying each. And so that's why we divide it by the number of sides. We're just dividing it out. So going back, it says, for a regular 50gon, determine the sum of the interior angles, the measure of each interior angle, the sum of the exterior angles, and the measure of each exterior angle. Now, it's asking us to do 4 things, but this is going to go really, really quickly with those formulas. So I kind of like to organize it like I had it on that formula chart with this little grid. And so I had that grid. It was like that little box. And remember, so if you're just looking at it, this was our interior sum. This was how I found 1, or each interior. And this is our exterior sum. And this is how I found each exterior. And I do want to have some work, but exterior sum's always going to be 360. So I can go ahead and fill that in. I don't really have work for that particular one. So if we go back, it said that it was a regular 50gon, which means that n is 50. So this shape has 50 sides. It's a lot. So to find my interior sum right here, remember that my formula was n minus 2 times 180. So I'm going to take 50 minus 2, and hopefully you can do some of this mentally, so mental math. So 50 minus 2 is 48, and then 48 times 180, we'll go to the calculator and type that number in. It should be pretty big. That makes the interior sum 8,640 degrees. Okay, to find each interior, or just one, I'm going to take that number. And I know a lot of you are going to show the work in the calculator, but it does help to write it out. Just in case there's a mistake, you can get some partial credit there. We could see where you went wrong. So I'm going to take that sum and divide it by 50. And I get a decimal, and that's okay. So the decimal that I get in the calculator is 172.8 degrees. Okay, to find one exterior, remember I take 360 and I just do 360 divided by, there were 50 sides, so 360 divided by 50, that's going to give me 7.2 degrees. Now, the quick way to check this is now that I've used all my formulas, now I'm just going to double check, do these numbers add up to 180? And they do, which means that I did it correct. So taking a look at the next one, it says for a regular dodecagon, so now n is going to equal 12. Determine the sum of the interior angles, the measure of each interior, the sum of the exterior, and the measure of each exterior. Some people like to write it out instead of like a grid. Some people like to do just one task at a time. So if we do it that way, so my interior sum would be, Well, go looking at that formula. So it's n minus 2 times 180. I'm just using this formula chart right here. So anterior sum is n minus 2 times 180. So I need to figure out, well, 12 minus 2 is 10. And 10 times 180 would be 1,800. Okay, now I need the sum to find one interior, or each interior, because now I'm going to take that number from before and I'm going to divide it by how many sides there are. Now, this is where a lot of people like to divide it by 10, but the shape didn't have 10 sides, it has 12 sides. So I'm going to do 1,800 divided by 12, and then you just go to the calculator and we get 150. Now to figure out the exterior sum, I feel like that's people's favorite because you just need to remember that the exterior always adds up to 360. And then to find each exterior, I'm going to take that number from before, so it'll always be 360 divided by 12, and that would be 30. And if I do a quick check, 150 plus 30 equals 180, so I did it correct. Now, these formulas come into place whenever I have a picture and I'm trying to find information on that picture. So in this shape right here, we'll count the sides in a second. I know that I'm missing angle A. So I have every other piece, but I don't know what angle A is. Well, if it had 4 sides, it would add up to 360. If it had 3 sides, it would add up to 180. So I need to count my sides and figure out what does this add up to. Now I can tell that it's not a regular polygon because my angles are different, but that's okay. I can still figure out that interior angle sum. That's going to help me solve this problem. So if I count, I have 1, 2, 3, 4, 5, 6. So this is a hexagon, which means that it has 6 sides. So if I want to figure out what all 6 angles are supposed to add up to, I'm going to use that interior sum formula, which was 6 minus 2 times 180. And that's going to tell me what the inside is supposed to add up to. So 6 minus 2 is 4. 4 times 180 is going to be 720 degrees. Now, I have most of the angles. In fact, I have 5 of the 6. So now I'm going to give you a minute. Add up the 5 angles that we know, and then we're going to subtract that from 720. So use your calculator or mental math if you want to. Go ahead and add those up. And if we add those up, it adds up to 585. So 720 is what I should have, and I'm going to subtract out 585. So 720 minus 585 means that the measure of angle A should equal 135 degrees. That's it. That's how we use the interior sum in a problem. Now this next one isn't an interior sum problem. This next one, if I look, I have my angles on the outside, which makes this an exterior sum problem. Well, we know that the exterior angle sum always equals 360. So I'm going to add all of these together and set it equal to 360. Now, the last one didn't add up to 360. The last one, they were on the inside, so I had to figure out specifically what they were supposed to add up to. But if they're on the outside, they're always going to add up to 360. So if I combine like terms, I'm going to have 2x plus 54 and 158 would be 212, and it's going to equal 360. Now, if you were going to solve that out, which we're going to cut out some steps, x would equal 74. And if I plugged it back in, then I could double check and make sure they all added up to 360. Now, taking a look at the next one, I'm going to give you a minute to think, what should this one add up to? Well, these are all exterior, which means that they should add up to 360. So I'm going to say x plus, combining like terms. It doesn't matter how many sides there are for this one because I'm talking about the outside, and the outside will always add up to 360. So I'm going to go ahead and combine like terms. So if I add up all of these numbers, I'm going to give you a minute to see what you get. Should get 314, and my total should be 360. So if I solve for x, I'm just going to subtract x, that missing angle, would be 46 degrees. And that's how we use that in a problem. Now, we can also use these formulas to work backwards. So if we know the sum, we can use that to work backwards and figure out, well, how many sides, what's the name of the shape? So this says, given the sum of the interior angles. Well, I need my formula if I'm going to figure out the sum of the interior angles. Remember that that's n minus 2 times 180. And what I'm going to do for these particular problems is if I'm finding the number of sides, I'm going to work backwards. So I know that this is my formula. I know that this is the sum. So I'm going to set them equal to each other and work backwards. So n minus 2 times 180 equals 900. And I'm going to work backwards to get n, and that's going to tell me the number of sides. Now, you could just scroll up and look on your chart, but remember that you won't always have access to the chart, but you'll always have access to your formulas. So on these particular problems, I'm going in backwards order. So instead of subtracting 2 first and then multiplying by 180, I'm going to divide everything by 180 first. So 900 divided by 180 is 5. So I have n minus 2 equals 5, and now I'm going to add 2 because I'm going backwards. Well, 5 plus 2 is 7, which would make this a heptagon. So we can use these formulas to figure out what shape we do have. Now, if the sum was 360 for the interior, we know that's a quadrilateral. If it were 180, we know that's a triangle. But if not, we can work backwards. So if this sum, if this interior sum, so n minus 2 times 180 equaled 1800, now I'm going to go backwards from here. So I'm going to start by dividing both sides by 180. So n minus 2 equals 10. And then I'm going to add 2 to both sides, so n would equal 12. And if it has 12 sides, think that's not a decagon, that's 10 sides, but 12 sides would be a dodecagon. And that's how I use this to work backwards. So even if we don't know what the shape is, if we have some information about it, we can work backwards to figure out what it is. So this one says, it tells you each exterior angle now. So if we write out our formula first, those formulas are helpful. So each exterior angle, that would be 360 divided by n. And remember that you'll have access to this chart. So I'm just looking at 360 divided by n, so right there. And then I'm going to set it equal, I'm going to work backwards. So if 360 divided by n equals 20, well, there was a little trick with trig, and remember that trick with trig, can't talk, is whenever x was down low, remember that we divided. So when n is down low, I can swap those out and do the same thing. So I'm going to swap those out. I'm going to do 360 divided by 20, and that's going to tell me what n is. So if I just go to the calculator and do 360 divided by 20, I get that n is 18. And 18 sides doesn't have a special shape, so we would call this an 18gon. And for this next one, we know that one exterior is 72 degrees. So following that same formula, so 360 divided by n equals 72. And I can just swap those out. So all I need to do is figure out what's 360 divided by 72. That's 5. So then this shape would be a pentagon. So don't forget to use those formulas for your benefit, and just remember that n is the number of sides. So if you're not too familiar with these names of polygons and the number of sides, I would take a look at this before starting on your practice. Good luck.